Here's our first lecture on electric circuits. Now, circuits are going to be represented by using circuit diagrams, and these help simplify the electrical circuit system. So we're going to have to learn that when we put items in our circuit board boxes together, we can actually draw them out using some, let's just say, diagrams, symbols. Circuits provide paths for current, right, charges to flow or move within a conductor. So the wires we're going to use, right, wires have a tendency of being metallic and copper at that, and they have these, let's just say it allows for current to flow. Electrons are able to move throughout the wire itself. So here we have a picture of a light bulb that's lit up. This light bulb that's lit up tells me, it indicates, right, the light itself indicates that electricity is flowing in the form of current through this circuit. Now this is a series circuit. It's traveling in one path or in one direction. Electric circuits are common to our lives as electricity is useful to life as we know it. So even though we see and use electricity all the time, we don't always stop and think about how and why it works. Well, in this unit we're going to. So let's start off by looking at this. Here we have an electric circuit here. We have a light bulb, we have a battery, we have a wire, and we have what's called a switch. And we'll be able to draw this with the circuit diagram. Here's our battery, here's a wire, here's a bulb, and here's a switch. Open and closed circuits. An open circuit means that the path for electricity, right, the path for the electrons to move is, well, let's just say opened. It does not allow for current to flow. So an open circuit is not going to have a light bulb that's lit up. There is no path for it to flow. It's been broken or opened. But a closed circuit allows for current to travel or to move. Now notice we're going to be identifying this picture here that current is going to be moving from cathode, that's the positive end of this battery terminal, right? We'll be using 1.5 volt batteries in here. Current is identified as moving from the cathode, right? It's going to be used by the battery or by the light bulb. It's going to flow from cathode to anode. Anode is the negative terminal of this. So an open circuit is not going to be lit up. A closed circuit, presuming there's enough current to light the bulb, it's going to be on. So you can just look at a circuit and get an idea if it's open or closed. So here are circuit diagram symbols. Parts of the circuit boards that we'll use in class contain each of the objects in the picture to the right. We'll be using all kinds of different wires. We'll be using 1.5 volt batteries, and we'll label these based on the positive and the negative end, right? These are the terminals. Cathode goes up here. Notice it's a larger kind of a upside down T shape. And the negative side, the anode, is a smaller T. The light bulb itself kind of has this like little squiggly line in here with a circle around it. Resistors, they just have these squiggles again, right? A light bulb actually is a form of a resistor. It actually uses electricity. And we have a switch. The switch is going to be able to open or close the circuit. So remember, if it's an open circuit, it's not going to light. If this were touching this metal conductor over here, well, let's just say electricity could flow. So we'll have two 1.5 volt batteries, we'll have several wires, we'll have several different resistors, we'll have one variable resistor that's like a dimmer switch. You'll want to watch the video to see that. And then we'll have one switch that'll be able to open and close the circuit itself. Well, here's a video I loaded in here. So this is the video. You'll want to watch this on your own. So after you've watched the video, this is a good little review because I introduce you to Ohm's law. Ohm's law is kind of the end-all be-all for electric circuits. It's simply saying that voltage equals current times resistance, or voltage equals, or V equals I times R. So if we were to begin drawing circuit diagrams, we can draw circuit diagrams, right, using our symbols, and we can start applying Ohm's law. Now we're going to start slowly. So if I were to draw a circuit diagram here, I would want to draw my circuit symbol. Here's my cathode, here's my anode. This would be a light bulb. This would be my switch, and I would have yet another light bulb. So I would have a switch, and those light bulbs were on, so I would want to have those touching, right? So this would be an open switch. We would want to close that. We'd want to have the dot and the dot and connected. We would have two light bulbs, and we would have one 1.5 volt battery. So that gives you a little bit of practice, and we'll do a lot of that in class. But now let's apply Ohm's law. V equals IR. Voltage equals current times resistance. So what would happen to the brightness, right? We're going to associate brightness with current if. So what would happen to the brightness of these two bulbs if I added a 1.5 volt battery? Well, let's think about this. If I go from 1.5 volts, if I add another one, I would go to 3 volts. If I had twice the voltage, I would actually have twice the current. So therefore, these would get twice as bright. So let's go back to this picture here, and let's reevaluate the scenario. So what would happen to the brightness if? What would happen if I added 2 bulbs? Well, let's think about this. If I'm adding bulbs, I'm adding resistors, right? And I'm asking about brightness. Well, the voltage isn't changing. So if I add more resistors, I'm going to be decreasing current. If I'm decreasing my current, they're going to get dimmer. So if we associate brightness to current, if I add voltage, they're going to get brighter because I'm adding current. If I add resistors, they're going to get dimmer. I'm decreasing my total current. This, once again, we are looking at a series circuit. This is a closed circuit. I have 1.5 volts of, 1.5 volts pushing current, and I have 2 light bulbs here. So we're learning the basics of electric circuits. There you have it.